Good morning. Welcome to our talk on v6-only networks, and if it's finally time for v6-only networks or v6-only deployments and v6-only, say, subnets, mainly in enterprise space. This is where we come from. This is Christopher. He's one of the line leads at ERNW. Old school network geek, has been doing IPv6 for a long time. Same applies to me. Funnily enough, in the morning we noticed that we don't have an introduction slide like who we are, as maybe this was a Freud thing of or Freudian. How do you say? We considered this space so familiar that we didn't feel we had to introduce ourselves. That said, what is this talk about? This talk was born from or originates from a project which we are involved in right now. I will give some details on the project later on. And one part of that is that in the customer organization, there has to be a decision has to be taken. If a large-scale deployment of Wi-Fi hotspots with v6 will happen in a v6 only or in a dual stacked way. And they brought us in to help them consult on, like, okay, which strategy could be best, not least based on the fact that at Troopers, as you know, in the interim, the default SSID has been v6 only since 3 years, 4 years? I think default since 3 years, yes. Right? And so we were asked, okay, can you provide some input if this is a feasible strategy or not? And we thought it could be worthwhile to first lay out what are the technological say options doing this. Then we will provide some anonymized details on the case study and our line of thinking in the course of that one. And at some point we decided, okay, we need data. Actually, both ERNW as an organization and for those of you from, say, international space, we Germans have a reputation of being very efficient and data-driven, and that's why we decided, okay, we shouldn't be able to take a decision just based on speculation, but we should build a lab and find out if v6 only really works. Namely for the specific use case, for the specific organization, as we will see, the traffic profile might be a bit different from the, say, the traffic profile in enterprise space, as laid out, for example, by Veronica in the morning. Before I get into it, some very quick stats, which we usually do when we talk about IPv6. As of today, with say 2 or 3 weeks delay. This is the IPv6 endpoint deployment in the internet. This is pretty much a similar slide as shown by Veronica. Right now, we can roughly state 25 to 27% of, say, IP-capable endpoints in the internet have IPv6 enabled. Then there is Germany. In Germany, as of today, it's roughly 40%. So 4 out of 10 systems being in mobile networks, being in cable-based networks, say in the home space, have IPv6 enabled. And roughly 29% of Alexa top 1000, with decreasing numbers once you enlarge the space of looking at say about 25 to 30% of main websites have IPv6 enabled. These numbers, besides presenting them every time we talk about IPv6, these numbers will play a role for the decision-taking process of in the case study organization. Second background next to that case study of this talk is that say we see an increasing interest of v6 only, both in general in customer space, and there is a number of actually conferences which nowadays have v6 only plus not 6.4. I will comment on this in a second, what this means from a technology, say, level. quite a few conferences have v6 only to a different degree, say, of maturity, to be honest. At Troopers, we think we have, of course, we are biased. We have a pretty mature v6 only SSID. At FOSDEM, it's the same. Not so sure about Cisco Live, to be honest. For one of two devices which I use, I couldn't use one at Cisco Live for reasons which I will discuss later. I wrote a blog post about this. Suffice to say that there is movement towards v6 only, especially when it comes to Wi-Fi networks and Wi-Fi networks in public space. Why would one be able to, say, motivated to do this? A number of reasons was laid out by Veronica already in the morning. Simply said, it's about, say, avoiding the operational cost and maybe even the associated capex, in the sense of you have to buy IPv4 addresses, avoiding dual stack. And I've been in conversations lately with organizations, and Veronica, again, she provided say, her own organization as one example of those. Organizations which even have pretty large IPv4 space allocations, and still they run out of those. Might be namely due to the increasing use of containers and systems running many individual entities needing an IP address. And once you have, say, container-based solutions which need thousands of IP addresses on a burn and chain basis, you can't do that with v4. And even the, say, RFC 1918 space will be used up very quickly. Dual stack, assuming pretty much everybody in the room knows what this means. Two quick comments from our side when talking about dual stack. It's not just systems have addresses from both address families. Two things to keep in mind is, first, routing protocols will need different routing processes, which increases complexity. And even if it seems you can run OSPF v3 with two address families, under the hood, it's still two processors, at least say on Cisco devices. Second thing for dual stack to be kept in mind is, once both address families are present, for a specific connection, a decision has to be taken if to use v4 or v6, and this decision-taking process can fail, can produce bad results, which then result in bad user experience, and it might induce an additional delay. Some of you might know there is this thing called happy eyeballs, and happy eyeballs is about giving v6 a head start, which simply looking at it means v4 has a time-based disadvantage, which from the strategy of happy eyeballs is perfectly legitimate, and it's even intended. From a user experience perspective, it might hurt, as long as you have a service running on v4 only. So a dual stack is not as say simple as it seems when looking closer. Then there is the approach of going v6 only with net64. This is exactly what's the focus of this talk. And here I will very quickly glance this, actually, as Veronica already told how this is going to work. One thing to keep in mind is there is one specific technology thing coming from the Google Android space, which is called 464XLUT, which is considered as an additional thing to fill the gap once specific applications are not able to work in a net64 setting. As the endpoint doesn't really understand, okay, here is v6 only, and I can't reach v4, maybe based on addresses, to interfere with the traffic on the local endpoint. From a service provider perspective, or say from maybe even from a conference organizer perspective running a wireless network, this might be interesting. To be honest, I consider this a thing which fills a gap which will no longer exist in a few years. I don't see really a future for this, but this is a whole debate in itself.
pushed everybody to purge IPv4 on the dependent applications.
Yep.
Even though they recently also introduced 464 in iOS. But
not really. They have a CLAT thing which does.
yeah.
But it's. I'm pretty sure that once you talk with an Apple person and you said, oh yeah, you support now 464 XLAT, that person, he or she would heavily reject that notion. In any case, talking about Apple, Apple has taken a different strategy some years ago, which is exactly as Veronica just mentioned. Google doesn't polish the Play Store. Apple does since a few years. They have a strict requirement that whenever an application wants to be listed in the App Store, it has to support v6 and it has to support v6-only, and you have to prove that you tested it in a v6-only network. There is Apple developer forums full of like, oh, how do I set up such a network to be able to test an application? And we had actually in trainings, we had people asking us like, oh, I'm from an organization developing apps, and I'm just here due to this strange Apple requirement. We will get back to this. As time tells, I think, to be honest, this was a very smart decision at the time. But we'll get back to this. So I mentioned there is a case study behind this talk. I've slightly modified some parameters of the case study, but let's imagine there is an organization which has a number of physical locations in a region, and this number is in the range of several thousands. And in these locations, say supermarkets, there is Wi-Fi hotspots, and they want to enable Wi-Fi v6 in those Wi-Fi hotspots, and face the decision dual stack versus v6 only. To be kept in mind here, or to notice, is there might be a very interesting traffic profile. There might be people, actually those supermarkets might be in malls. People might sit there for a long time, like an hour or two, and use the Wi-Fi. This might be, say, students after school playing online games. These might be, say, refugees connecting, looking for Wi-Fi, offering to connect with, say, with family members. So it might be heavy focus on communication apps. There might not be so many, say, corporate VPN clients, might not play the role it plays in a corporate guest network. And there might be, say, additional, like bakeries in the supermarket, which have IoT systems. And while there might be, say, for such a bakery, contract-wise, they might be forced to use for their cash systems some offering from a service provider. Still, it will happen. They bring in displays, or there will be IoT devices. That's an assumption for this type of deployment. Also, to be kept in, this is a question they are facing. To be kept in mind is this is like a free offering. So strictly speaking, there is no SLAs. From the organization's perspective, they could take a stance of, we don't care if anything doesn't work. This is not a paid service. But, of course, well, they would like to avoid discussions. Well, just recently I was using the Wi-Fi in, say, at Tesco's, and it didn't work. And they have such a shitty customer service, and now their Wi-Fi doesn't work. So they, from a brand perspective, they might like to avoid these types of discussions, even though the service itself is free. So when we were asked how to tackle this, we initially came up with a matrix like this. We had a number of conversations. Among them, we talked to Veronica. Thank you again for your input. Like, okay, what do we see in what have you seen in the Troopers network? What do other people tell us about things not working? What are known things in the internet? And I have been I'm somewhat active in the so-called Freifunk community, and there is say wireless public networks. There is people who have enabled v6 only on a test basis there as well, and they have seen things. So we had a number of conversations, and we came up like, okay, this is what we expect. This is mere speculation. I'm not even happy. I noticed that people took a picture of this one. Okay, thank you. This has been kind of replaced by a data-driven approach in the interim. But at the time, we were like, okay, this is what we think will be the space once there is users with these types of devices. Native v6, no problems to be expected. But what happens when Net6 comes into play for these types of say applications? There is we expect anything using mere HTTP and HTTPS to work nicely, and this has been later confirmed in the lab testing. We knew that this one is, we might face problems here. And here it depends a bit on, say, maturity of the application and type of the application, and if it's a multiplayer game. Multiplayer games have very specific requirements as for the network connectivity, stuff like this. So we don't really know. What came into play, or before I mention this, before I talk about trends or say additional thoughts, this is from the recent FOSDEM, which happened in early February. They wrote in a very interesting blog post about their experience with the v6 only. And it turned out that they have the impression that people moved from the v6 only to the the dual stack network explicitly when they wanted to use IPsec-based VPNs. The reason for their speculation is that they merely saw IPsec in the dual stack network. They didn't see much IPsec in the v6 only. So this confirms, actually, I included this as this kind of seems to point in the direction which we expected here. But actually, it might be better than these numbers might indicate. So for the decision-taking process in the case study organization, I think that played a role is trends over time. The project just started. There will be pilot deployments during this year, but the majority of actual sites and locations will be deployed in probably in 2020. So it might make sense not to talk about what we see today, but what we will see in like 12 to 18 months. And we try to understand the, say, some current developments. And what we expect is that the number of native v6 is increasing. So this part of the picture where we don't expect or see any problems, this amount is growing. At the same time, the amount of, say, applications which do not work in a Net6 setting might decrease for the simple reason there's the Apple requirement. And while the Apple requirement is in place since 2016, so one could say, well, it should cover 100% of applications as of today. You have to keep in mind there's applications which have been in the App Store before. And I'm not, to be honest, I'm not sure how strict Apple enforces this for updates. So if there is an application which has been in the App Store since 2014 and there is an update, does this requirement cover the update or not?
I would say, based on my experience, what I've seen with our product groups, if it breaks, they get pretty strong pushback from Apple. So it was working like it was working before. We had one app which is actually on Apple TV, and they had issues, and they basically needed to test because they couldn't reproduce the issue with with a hotspot on Mac. So
Yeah.
I think they're purging it, but it depends how much user complain, what is revenue generating, etc.
Yeah. Actually, this is the, we will later see that the numbers confirm what you were, the actual data confirm what you are saying. We expected, in any case, we were like, okay, if there is issues with apps, over time they will decrease. So time is in our favor here. And the same for the VPN clients. We knew that, Veronica, you were talking to Windows. There's another organization which we know is talking to Windows. So we were like, okay, maybe next year, in 12 months, the number of potentially problematic things will have decreased anyway. So overall, these are the trends I just laid out. Overall, we were our proposal to the customer organization was, well, based on what we think and what we expect, we would recommend going with a v6-only approach. But still there was like, well, we don't really know, it might be problems, and what if then there is on the public forum shaming and stuff. There was still a degree of uncertainty. And that is where we decided, let's build a lab. Let's try. Let's really look at specific applications in a test lab and find out, are there issues or not? And this is, I think, for most of you, the more interesting part of the presentation.
Hopefully. Yeah, thanks. Yeah, and actually getting this data, as Anna mentioned, we had quite some discussions internally what should we propose? Should we propose go for the IPv6 only approach with NAT64 or go the dual stack approach? Anna was, well, screw it, we just go IPv6 only. I was more hesitant, well, we should be more careful due to the potential social media backslash in case something doesn't work. But in the end, after quite some lively discussion internally, we decided to go, go IPv6 only with NAT64. And just to get a better feeling for myself, not only a gut feeling, we decided, okay, we should build a lab and just test it to get reliable data. And that's exactly what we have done. So basically, we put up a pretty small lab, which just consists basically of a couple of devices. We have just a Cisco ISR router acting as a NAT64 gateway. We have an unbound DNS server acting as a DNS64 server, and we have a Wi-Fi controller and an access point for the Wi-Fi connectivity for the smartphones or the mobile devices. So on a schematic theme, this is basically our lab setup. As I said, pretty basic, nothing out of the ordinary. The router was connected to the v4 and IPv6 internet. We have our wireless controller, the access point, and the laptop, iOS and Android devices. So when the lab setup was done, we thought, okay, what kind of applications shall we test? So, but before going into this, we have, of course, taken a couple of devices and operating systems which we wanted to use or wanted to test. We have, of course, Windows 10, latest build as of last week, build 1809. We have an older Windows 7. We have the most recent Mac OS version, Apple iOS, Arch Linux, and Android version 9. I'm not an Android person, but this should be at least the most recent version as of right now. And just to get a feeling, okay, do these operating systems and do the applications running on these operating systems really work in an IPv6 only environment? So after this, we of course had to create an initial set of applications which we wanted to test. And as Enno said, based on the use case and the case study, the applications we have chosen might not be, or not all are business relevant for corporate environments, but still we try to find a good balance between to be expected applications in the free Wi-Fi service and compared to applications which we typically see in corporate environments. So before going into the specifics, we have basically created categories of applications. For example, social media, which would be Instagram, WhatsApp, Twitter, Flickr, Tinder, and stuff like that. Then we have communication. Communication would be, what about all these collaboration applications, Microsoft Teams, Slack, WebEx, Skype for Business, Skype Consumer, and so on. So, so after we have created these categories and identified the applications which we wanted to test, we of course created test cases for each application because we of course wanted to test, okay, of course, or is the app working within an IPv6 only environment? And if yes, can I use all functionality which is provided by the app in an IPv6 only fashion? And as we will see, there are some things that do not work, but to cover these cases, we just created these tests. Then, of course, perform the tests, and in case something does not work, we try to evaluate, okay, what is the actual root cause of the breakage, so that we can, in the later stage, talk to the vendor and hopefully get it fixed, so that these applications are working in an IPv6 only fashion or an IPv6 only environment. So these are the categories which we have chosen. As I said, this is just an initial set of applications. This is by no means an exhaustive list, and we are happy for suggestions. If you see any or want to get tested any application, we can do that. We see this as an ongoing effort, so the lab is still there, and we will do further testing in the future, of course. So please approach us if you have any application you want to have tested. I omitted the specific applications here, but I have the applications are listed in the appendix just for brevity reasons. So, and then of course we needed to document this. This is just a small sample of the test cases. I will come to that back later. So basically what we see here is we have basically our category. Do I have a laser pointer here? No? Okay, then we have here the applications we have tested, Signal, Instagram, Snapchat, and so on. And then what we see here are the operating systems. And then we have just a basic metric. Green, everything is fine. Everything is working as expected. The orange basically means, well, there is no application available for the specific operating system. And then there's some yellow, which you can see here. Yellow basically means, well, there are some problems within the usage of the application, but we will of course release all the results of the test cases after the presentation as well, so that you can get a better understanding what we have tested and what the results are so far. So first I want to thank Marius. Is he here? No, he isn't. He is one of our students, and he has basically performed the majority of test cases in the last 3 weeks, so kudos to him. And before we're going into specifics, just to get or giving you a quick overview, from an OS-wise perspective, iOS apps successfully completed all test cases, which wasn't that surprising given Apple's strategy regarding the requirement of IPv6 support within their apps. From a category perspective, most of the categories work quite nicely. For example, social media and communication. 2 issues or 2 areas where we identified issues are games, so the typical hottest games which are currently played by the younger generation, and on the streaming sites. And when we observed these type of problems, we could observe 2 failure scenarios. Either the app just doesn't work at all without IPv4, so I even do not have the possibility to log into the application, for example, or the app in general works, but some features are not available within the app, and I will show some the details in a couple of minutes. So, sorry? This slide is still for Apple, iOS? Well, this is just a general slide. As you can see, as iOS have successfully tested completed all test cases, we haven't run into any issues for iOS apps in this case. But this is just the general issues we have faced, regardless of the actual operating system. But as I said,
And if you look closely, that's an Android-based. So.
Yeah, no pun intended. So, from a streaming perspective, in the streaming category, what have we tested? So we have tested, of course, Spotify, Apple Music. We have tested Amazon Prime Video and Music. And Spotify is one candidate which is known to not support IPv6. Looking at a blog article from the Spotify labs back in 2015, and they were discussing, well, yeah, IPv6, and then they have written, well, enabling IPv6 for a client application is not technically a big deal. Then one might ask, okay, why haven't you done it? And then a couple of paragraphs down below, they say, well, unfortunately, our client code had its own IP address type, which didn't support IPv6, and it also assumed that the IP address fits into 4 bytes in numerous places. Well, of course, this doesn't work well with IPv6 when you have 128 bits. So, but this was 2015. I thought, well, okay, maybe things change. And at least in the interim, for Android and iOS devices, the Spotify application works well, and it's just working as expected. But for the application which you can install on macOS or in a Windows space, it just unfortunately doesn't work. And I said, well, maybe we get, are there any information available? And then what I found in the community of Spotify a blog or a forums entry, basically IPv6 support that dated on the 30th of April 2018. When will we be able to use Spotify without IPv4? And they seem to have a kind of system within their forum. If someone thinks this is a good idea, then someone can update it. Yeah, well, marked it as a new idea. Yeah, absolutely, that's a fucking great idea. Sorry for that, to implement it. But nothing has changed since then. So basically for nearly 9 months, it still has the status of a new idea.
I'm going to give you a workaround. It works in a browser.
Yes, yeah, absolutely. Yes, that's correct. This is what I was referring here to. I'm specifically referring to the application which you are installing on your Windows 10 machine, for example. If you're using the web client, as the client is using the browser stuff, it works just fine. This only applies to the application you are installing. And basically, it just fails completely. Here on the right, you see the normal login screen, and it doesn't do anything. And I wasn't able to observe any network activity during the login process. So my assumption, I'm not sure whether I'm right or not, but my assumption is that the application is looking or tries to open an IPv4 socket, recognizes, well, screw it, I don't have an IPv4 address and can't open an IPv4 socket, and then completely fails.
Just try it at the moment within the Troubles SSID and it works.
Yes, that's your iOS version. I'm specifically referring to the Spotify app on Windows 10 and Windows 7 machines.
That's the Android version.
Yes, the Android version does work as well. So for Android and iOS, as I said, on every platform, it works as one should expect, with the exception of the application you can install on the Windows 10 box or on your Mac OS for whatever reason. And as I said, I wasn't able to see any potential network traffic that would relate to the establishment or to perform the authentication. So my assumption would be here that the application tries to open up IPv4 socket as the application or as the operating system has only an IPv6 address. It just fails, and then it tells me, well, the firewall may be blocking Spotify. Well, that's not necessarily the case. But this is my assumption in this scenario.
And this is interesting, if I may jump in.
Yeah, sure.
As once you consider deploying v6-only, think about your user base. One could ask, okay, how many of the expected users, say in a supermarket or in a mall, will really will fire up their laptop running Windows or Mac OS to use Spotify. Is this really a relevant problem? Even if recognized, will it affect user experience in a way that, say, hurts my business or the brand or whatever? And the second thing is, once there is cases where it actually works in specific settings, but not on other operating systems, then one can clearly state it's a vendor problem, which can be used for the communication. It's not like, well, you know, we have this exotic thing called v6, and it's mainly a network problem. But this means, okay, it actually works in specific cases. It just doesn't work in others, which means vendor hasn't done homework, or has to take a decision, we don't want to support it, given this is not a relevant user base for us, which then again is a decision. But this has an impact on how to, on the aspect of communication, which, as Veronica stated, communication is crucial. And this changes, say, the communication path, potentially.
Yeah. So, based on the use case Anna already described, we expected, okay, that the user base will be using quite a lot of games for from different vendors. So, of course, we tested a couple of game clients. So we started with one of the most famous or prominent, which is the Steam client. And before going into the specifics of the testing, I just did a little bit of research to see, okay, to get an idea, does the Steam client support IPv6? And then I was pleasantly surprised to find the tweet from Eric, where he mentioned, okay, that the Steam downloads are now available over IPv6. I thought to myself, well, that's good. Hopefully the client will work as well. Unfortunately, he does not. While I could just download and install the client without a problem, for the Steam client, it is always the case when you're starting, it tries to contact the update server to see whether there are any updates to the Steam client itself. And here it's the same thing as with Spotify. I haven't been able to observe any network traffic when I'm starting the client. So basically he just completely fails directly and tells me, well, I need to be online. Well, I am online, but not with the protocol you are expecting. So basically the same, or assume the same problem as with Spotify in regards to that. It expects an IPv4 IP address and tries to open an IPv4 socket. So next thing, Fortnite. As I've been told, Fortnite is the latest, hottest battle royale, whatever this is, a game for a year or two. So I never played it myself. The only thing I know is, well, Fortnite was developed by Epic. Epic is a developer studio. Where they are also providing the so-called Unreal Engine, which is basically an engine which they have, I think, open sourced, and third-party developers can use this gaming engines to create new games. So, and well, I said we expected within the Wi-Fi environment, there will be quite a lot of teens or younger generations who want to play Fortnite. So we just gave it a go and tried to evaluate, okay, does Fortnite work in an IPv6 only fashion? So, but to play Fortnite, you have to install the so-called Epic Games Launcher. This is a prerequisite which needs to be installed. Basically, it's just the a gaming browser, I would call it. So if you open the client, the Epic Game client, you see some content. You have here your menu where you can browse the Epic Store, where you can, of course, buy new games which are released by Epic or some third-party developers. We have a library and so on. And this was working all quite nicely over IPv6, so no problems here. But what I realized, well, wait a second. It tells me here, friends online 0. Well, so, and we had created a couple of accounts just to test and connected them each other over IPv4 just to see, okay, so that we have some friends we could potentially play with. But unfortunately, as it turns out, XMPP doesn't work in the Epic Game Launcher. It just tells me that it's offline, and I am not able to get online. Well, and I thought to myself, okay, that's interesting. Basically, the whole Epic Launcher works works in an IPv6 only fashion, but only this specific functionality, XMPP, doesn't work. So of course, we have performed and created some traces, and it turns out that even in an IPv6 only environment, the XMPP client, which is part of this Epic Games Launcher, is just asking for an A record and not asking for a quad A record. Of course, he gets an answer, but this ultimately fails because he has no IPv4 address which he could connect to the provided IP addresses. So my assumption would be here that this is a bug which we will communicate to Epic, because everything else within this Epic Launcher was just working fine in an IPv6 only fashion. But this is a pretty obvious case why it isn't working, and it should be easily fixable. Because what is not listed here in the on the slide, but what I could observe is when the Epic Launcher client or the Epic Launcher client is performing various DNS queries to a number of the different domain names, and every query consisted of an A record or an A query and the quad A record, but only for XMPP, the update or the client is only doing the update, the DNS query for the IPv4 address. So pretty obvious case, and we would consider it as a bug.
In general, we will follow up on all issues we identified with the vendors, and we will both publish like the results kind of the ongoing communication, and we will provide like templates how to phrase vendor communication. Like, okay, we have in a way that I mean, we will write those in a nice way, but still in a
friendly way.
Like, okay, this is not, it's 2019, and all of your peers, your competitors support this. It's just you who doesn't, well, again, phrased nicely, but in a way that it's not like, oh, we apologize, we have this exotic network environment. But hey, this is standard, so you have a problem, not the. And we will provide templates for this.
Yeah, okay. Well, I mean, not able to play with your friends might be is a limitation, but what about just using the game? Well, here it gets interesting as well. You can't just start the game normally. There is some form of lobby. So basically, you start the game, you are first in a kind of lobby where you are waiting for a match to be prepared. You can download content. You can contact the so-called matchmaking server, which will then create the game, and everything is working fine. The application is transitioned to the loading screen, which at least indicated to me in the beginning, okay, it could work. But unfortunately, when the loading screen was done, he just got disconnected and just got this error. We hit a roadblock, network connection lost. As of right now, I wasn't able to verify what exactly causes the game to fail, so I need to dig a little bit deeper into it. Of course, what I have tried in the first place is, okay, does the game generate any form of log messages which would give me an idea or an impression what went wrong? Unfortunately, while it creates log files, the log files are very, very helpful, at least to get the root cause of the issue. As we can see here, the only thing what he was telling me as well, Windows client reason network connection loss. Well, yeah, thanks, but I haven't noticed by myself. So at the end, as of right now, you are not able to play Fortnite in an IPv6 only network.
I don't know if that's the case for that game, but what might happen is that there are applications that need UPnP.
Yeah.
The CPEs, they don't have UPnP support for v6. They do have for IPv4, but not for IPv6.
Yeah.
So if you have a stateful firewall on the CPE and they don't have UVMP support,
yeah, that could be the case. As I said, I need to do more research to get hopefully the root cause sorted out. But thanks for the point. That could be an issue, yes. But I need to double check that.
Could also be that it's not really the game itself. Since it's looking pretty fishy, it works. It can connect to the matchmaking server.
Yeah.
But it could be that the problem is the anti-cheat, which is running in the background, and they talk to the mother, back to the server, and they do some ping-pong with
Okay.
different servers. So it could be that the game itself could run, but the anti-cheat is blocking it, which is most of the time a big problem for Fortnite and other similar battle royale games.
Yeah. Okay.
Because it's a big issue in this from this player base. So they have to do way more security checks, even via network.
Yeah. Okay. So thanks for the point. I wasn't aware of this anti-cheat mechanism. As I said, I never have played it, so I'm not familiar how all this stuff works. But thanks. This could also be the reason. As I said, I will take it into account when I'm performing further research. So, but after I wasn't able to successfully identify what was causing the issue, I still did a little bit of research in regards to, okay, how is the IPv6 support for Fortnite or for the Unreal Engine in general, and I stumbled over some bug entries within the Unreal Engine forum. This is one just a typical example. This is from mid-2017. There's some third-party developer. He wants to develop an Android and iOS multiplayer project, and now due to new Apple policies, they are forced to make the app IPv6 capable and having a hard time doing that. Why? Because as it turns out that the Unreal Engine wasn't able to handle, at least mid-2017, to handle IPv6. And this discussion was going back and forth. Well, you should be dual stack, but our backend is an AWS, so it should theoretically work, yada, yada, yada. And then one thing which caught my eye, well, hey, Matthew, we deal with Apple to bypass the requisite for now. Well, I'm not sure that they have been successful with that. But anyhow, as it turns out, they found out what the actual problem was for the Unreal Engine itself. As we can see here, the issue is typical as the same as with Spotify, the structure. There's no structure to hold 128-bit IP addresses. And as we can see here, this is just 32-bit integer for the host resolution, name resolution part. So the Unreal Engine wasn't able to store an 128-bit IPv6 address. But in the meantime, as I said, and as you can see on the timestamp, this was mid-2017. But it got fixed in the interim, luckily. But this is a great example for the Apple policy is working as expected. So we have a developer here who basically doesn't care about IPv6. The only thing he cares about is getting his multiplayer game up and running. But now, due to the Apple policies, he has to be exposed to IPv6, needs to know what is up with IPv6 and needs to implement it. So kudos to Apple for this approach they have taken in 2016. It really does a great job increasing the IPv6 capable apps. But this is just a side note, and here what I have found, this Unreal Engine released in November 2018, they seem to have improved the IPv6 support. They have merged it into a single socket subsystem. Well, I'm not a programmer, so I'm not sure what the applications are when IPv4 and IPv6 are in different subsystems. Now they're in one. At least it seems to me that it's better now than before. So that's a good thing. Yeah, we are on a good way to go.
Which somewhat supports our impression that things are moving in the right direction. if you look at, say, these ongoing discussions in forums for applications, there's quite somewhere like 2015 or so, something pop up, and it has been around for a while. And but in say second half of 2018 or early 2019, there was some momentum. Like, okay, we realized this is an issue, and it either will be fixed or it is already fixed. So this is a bit of a difference to earlier years.
Yeah.
It's up to you guys, it's up to everybody that we have to put the pressure.
Yeah, absolutely.
Because without that,
Yeah, absolutely. So these were just some cases where it hasn't worked. In all other cases, it works or it worked as expected. I mean, when I started the lab testing, we expected some minor breakage of applications, but at least I thought it was higher, the amount of applications that do not work in an IPv6 only fashion is higher than based on our data, it's pretty minimal. For the prime examples of applications which are going around not working over IPv6, for example, Skype, the consumer side, is just working fine in an IPv6 only fashion, regardless of the underlying operating system, be it Android, be it iOS, even on Windows 10, it's just working fine. We have tested it. The same for Skype for Business, which is of course another application, and for Cisco WebEx, this is all just working, and at least from an end user perspective, it's fully transparent, and they even know, and they shouldn't care whether they're using IPv4 or IPv6 as a transport. And primarily apps on the mobile devices are just working fine. The area where we need improvement is your applications which are installed on your typical workstation, be it a Windows, Linux, Mac OS. But for the mobile applications, we haven't had any issues, at least for the applications we have tested. As I've said, this was just the first iteration and the first set of applications, and this is by no means an exhaustive list.
Still, it's several hundred use cases. Already.
Yes.
Test cases.
Yeah, divided.
I mean, we have the appendix.
So, and we tested basically, I think, 25 applications, give or take. And depending on the amount of applications compared to the amount of applications that have broken, I think, or it's a pretty good result from an IPv6 perspective. 25
applications multiplied by individual test cases, a login, perform some function, maybe I would say 3 or 4 per application, multiplied by the number of platforms. So actually, Marius, he had some work
to do. Yeah. So basically, these were very positive results and gave me a better feeling to support the approach or the decision. Well, go IPv6 only in the Wi-Fi network. So what are the next steps? Well, of course, I need to investigate and validate the failure cases so that we can just create or describe the failure scenarios and then communicate with the vendor to hopefully get it fixed rather sooner than later. But this, of course, depends on how the vendor is communicating back with us. So, and as I've said, we will release the whole set of application, the test cases, and the sanitized PCAPs shortly after the presentation, of course. So, yeah, just testing more applications. What we haven't specifically tested are VPN clients. So as of right now, we can't comment on that. Of course, there's some information floating around which VPN clients do work and which not. But we plan to introduce them or integrate them into the testing series as well. And as I said in the beginning, we see this as an ongoing activity. So please feel free to approach us for any suggestions about applications, use cases you potentially have in your environment and seem relevant to get a better understanding. Okay, does this use case or application really work in an IPv6 only fashion?
I mean, I'm looking forward to your Gabriel presentation later on, as you have tested some like corporate stuff across the Net64, right?
Yes.
So things might become interesting there. Like Active Directory replication, walking through Net64, yes or not?
So, what's the time? 3 minutes left. So, besides the actual testing, there are some other areas or additional aspects, of course, which you should take into consideration. Basically, monitoring on telemetry. So, if you are providing an IPv6 only environment, that you have the capabilities to have telemetry data, which you can use to get a better understanding and idea, okay, what is the traffic profile within my network, especially in regards to IPv6? Does everything work from an IPv6 perspective? And then one important point is measuring progress. So you should be able to measure your progress for your IPv6 deployment. General communication, this is something Veronica told us where we had the discussion that communication is key, as in many aspects of life, with the users and with the management. Be transparent so that they know what they're up to, and this is an important point. And then, of course, as Veronica also told, incentivizing the use of v6 only. Microsoft is doing this with Starbucks stuff. And we have thought about it, how can we, at least from a conference perspective, incentivize the usage of the TrueBus SSID, as Enno has already told. We have the v6 only SSID, but still, for the last 2 or 3 years, the participation in the legacy SSID is still higher compared to the v6 only. From a ratio, 60% of the clients are still in the legacy, and 40%, I mean, I can show you the stats in a minute, and 40% are connecting to the v6 only SSID. And before the conference, we discussed, okay, are there any ways to incentivize the use of the TrueBus SSID? And at least for the conference context, we came up with 2 ideas. So basically, if you can prove that you have used DV6 only SSID over a longer period of time, not only connecting once and then disconnecting, you will get a token, but this will only start tomorrow because we have a charity auction and an auction in general where you can win stuff, but you have to submit tokens. And if you're using DV6 only as SSID, you will get 1 token, and this is 1. And if you are...
Actually, it's a bit different.
Is it?
Yeah.
Okay, then we are not aligned.
Yeah. Actually, we enforce it slightly differently.
Then
the latest, there is a set of, as some of you already know, there's these challenges, which are very sought after. There's many participants in trying to assemble points for challenges to be solved. These challenges can be like CTF-like stuff in the TrueBus network, but tokens will also be handed out, say, for participating in the run, by the way. We will hand out a token once you can prove, say, you're in the v6 only for any application which in a default setting doesn't work, and you can explain to us it doesn't work. That gives a token. And if you have opened a vendor ticket, that gives an additional token. That is the latest.
Yeah, okay, then...
And we even thought, if I might, we refrained from this, but only because we didn't have enough time for discussion and testing. But we seriously considered making the user experience, turning down transmission rate for the legacy SSID.
Basically, we thought about just deactivating the 5 GHz band completely for the legacy SSID, but...
So really like punishment. Oh, you're using legacy stuff? This is
then
a
you
technology conference, you shouldn't.
Yeah.
Or if you want, the thing is, there is a number of, say, IoT, the badges. Have some network connectivity, but that is in the legacy. No, that's
it's a completely separate SSID for the badges.
Yeah, but we the idea was then again like, okay, put the IoT crap just in the legacy or in the 2.4 band. Like, so if you really want to do this, you can, but you will suffer.
Yeah.
This is like the liberty we have as conference organizers. But we seriously thought about how can we push in a say friendly setting like Troopers things towards v6, and the incentivizing way with the tokens is what we did. We refrained from the punishing side. Yeah.
But maybe we're doing it next year when we have a little bit more time for testing all the stuff, because the problem is here. The venue is clustered with foreign access points, which I do not have any access to, and I just can't disconnect them even if I want to. So in the 2.4 gigahertz, you have basically 80 to 90% just interference. So I was reluctant to say, okay, we'll do it this year, but we have it on the agenda for next year. So if you really want to use legacy IP protocol, then you should use legacy Wi-Fi technology as well. Still, so I need to speed up because we are already 3 minutes around the time. Just
Fernando and Eric, if you're okay, starting 15 minutes later. I mean, you're okay anyway.
I mean, he's here, so. So just 2 minutes about the monitoring side of things. We thought about before the conference, okay, we just want to get a better understanding about NAT64 statistics, specifically on our gateway, for example, okay, how many translations do we have at any point in time? How many translations do we have in total? How many are currently? So, and what is the usual way you get to retrieve data of a network device? It's typically SNMP. Unfortunately, as it turned out, there is no OID available that I can query the NAT64 statistics or translations. So what do you do about it? At least in the Cisco space, the first thing you're doing, of course, you're doing a little bit of research, and then you have the CNSP mailing list, and just drop a mail on the mailing list whether someone has any idea. Unfortunately, there was this nice guy, Nikolai, which wrote me an email in a one-to-one conversation and told me, well, yeah, I had the same problem, but for his specific scenario, it was for the IPv4 NAT entries. And what has he done? Well, he has created a so-called EEM template, which is the embedded event manager within Cisco devices, a form of pseudo automation, I would call it, or scripting language within the Cisco devices. So, and he just sent me his template, and basically it was working out of the box. The only thing I had to adjust was the relevant show commands, and then it worked out of the box. And what does this template do is performs the show commands, parse the output with some regex magic. Then there's a specific SNMP expression MIP where you can store this value, and this value can be queried over SNMP, and you're doing the same stuff every 30 seconds to create your data. And then if you're looking at the data, these are the NAT64 translations for yesterday, Monday, from 7 a.m. to 10:09 or p.m. And as we can see here, at around 10:30, we had quite a spike to 30,000 active translations. I don't know what caused it, but it was interesting to see. And so in general, or in the average, we have around, as you can see here, I would assume between 7,000 to 10,000 active translations on the box down below. We can discuss this in a one-to-one due to time constraints, okay? So just for reference, this is the complete EM template, which I do not want will comment now. Last thing is telemetry for DNS queries. So the other thing we wanted to get a feeling of is, okay, actually, how many clients are using the DNS server provided over route advertisements, and how many clients are using the DNS server provided over stateless DHCP-v6? So how have we done it? Well, basically we just spun up 2 instances of Unbound, and basically Raphael has installed them, and we provided one each for the route advertisements and one over DHCP v6 to get a feeling, okay, how many clients are using the DHCP v6 versus the route advertisement provided. And of course, we are not logging what you are actually querying. We are just logging the amount of queries that happened. And these two DNS servers are solely used within the Troopers SSID, so they are not performing any lookups for clients within the legacy SSID, just only for the within the IPv6 only network. And as we can see here on the left side, we have the queries for the route advertisements. On the right side, the DNS queries for DHCP. This is also from 7 a.m. yesterday to 9 p.m. yesterday. And what we can see here is that we have, for the RA provided, we have a total amount of 220 or 219,000 queries compared to 240,000 for the DHCP provided. So it's pretty even in regards to the usage of the DNS servers.
This is probably speculation on the reasons. Might be there is a number of people in the workshops who are Windows-based laptops. Otherwise, if one would expect the DNS as related number of queries to be higher than the DHCP related one.
You're replying they're using the version before April 2017?
No, not necessarily, because at least from our understanding is if the Windows 10 box receives the DNS over RA and DHCP v6, he prefers the DHCP v6 one.
It only uses the DNS one if it doesn't get any DHCP.
So, and yeah. So, and it was interesting to see. So we have a pretty more or less even distribution, give or take. And yeah, famous last words. Of course, you should ensure high availability of your DNS and NAT64 components, and you should of course do or implement monitoring capabilities during the early phases, and be transparent with your user base.
Did you also test Linux in your test lab?
Yep.
Yes, we did.
How did it perform?
Quite well.
Same as Windows and Mac OS?
Yeah, there haven't been any specific cases where applications specifically haven't worked under Linux. So
once they were available.
yes, once
Linux.
they were available, of course. If there is an application available or all this web stuff is just working fine under Linux. We have just used an Arch Linux. The latest one was a 4.19 kernel, I think. So pretty recent, and nothing out of the ordinary. It just worked under the assumption that the application was available under Linux.
So final conclusions.
Conclusions, yeah.
Okay. Well,
I mean, you started the sentence, so I thought you want to give the final conclusions.
As I mentioned in the beginning, we see a number of growing interest in v6 only for good reasons. And actually, as the talk started with a question, is 2019 finally the year for maybe not Linux on the desktop, but v6 only? We would say yes. We are mostly there. Second thing, testing is important, as it creates an understanding what really happens, and you will be able to take well-informed decisions and to communicate in a proper manner. Like, okay, this is what we've seen. It's not speculation, but we know what is working versus what doesn't work, and we are able to communicate with a window. So this is why, in hindsight, we say we should have started with the lab even earlier.
Yeah, absolutely.
And the lab has provided so much insight, and this is why we will go on with this, as we think this is a community. This is a good thing for the community to really have an understanding what works and what doesn't. And one thing is, actually, we were surprised in Apple space, pretty much no problems, which then again seems to confirm the strategy in 2016 was a good one.
Yeah.
That's it from our
Yeah,
side.
thanks for your attention.
And